All right. Thanks for joining again. And my name is Adam. So, so before we jump into the technical side, what I want to do is just give you the agenda of what we will be understanding in the session. So, before moving into the technical side, let's first understand what is the problem statement that we are trying to solve using Docker or containers. So that is the first thing we need to know. And following that, we will understand the concept called containers. And then we will understand what exactly is Docker. And following that, we'll try to understand the difference between VMs and containers. And post that, we will try to learn what are the different components that we have in Docker. And then we will try to see how Docker is set up and what are the day-to-day activities that you will be doing. Okay. Now, in that, if you say Docker, there are typically three kinds of work that you will be doing. One is called as container management. And this session, what we have planned is going to completely focus on how are you going to manage the containers. That is what is all about. But however, we also have a couple of other things that we need to know from Docker is image management and container orchestration. And when I say container orchestration, this is where we have typically tools like Swarm or Kubernetes coming into the picture. But as I said, to start with, our focus will be completely on understanding what is Docker, what is container, and how is that you're going to manage the containers using Docker. Okay, so with this agenda, let's get started. Okay, now before we get into that, let's understand some of the use and concerns. To explain that, let me take up a simple example. Now, I believe all of us go to a vacation, right? Now, when we say we are going to vacation with our family, we book a hotel and we go there. Now, in the hotel, depending on how many people that we are going in, we might take a small room or a bigger, luxurious room, depending on your need. But the point here is there will be many people along with us staying in the hotel. Okay. Now, when we stay in the hotel, there will be a specific room that is being given to us. And we are completely free to use that room or anything within that room until the duration that has been allocated. So that way, many people will be living together in different rooms at the same time. But as I said, we are free to use those things that we have inside the room. But in a hotel, there are certain areas which we need to share other than the room, right? So things like parking lot or lobby, or especially when you say kitchen, these are the things which we have to share. Now, when I say sharing, we will not have a concern in sharing lobby or sharing a parking lot. But specifically, when you talk about kitchen, there will be some concerns in sharing. Now, if you are specifically, a hardcore vegetarian, then what happens is you will not be comfortable in sharing the same place or the kitchen which has been served for non-vegetarians. Now, what happens in that case? Now, let's assume that in the morning, it's been told that there's a free breakfast. So you go to the kitchen and or you start having your food in the restaurant. Then you realize that they serve both vegetarian and non-vegetarian at the same place. So you will not be comfortable. So what will you do for this? You have to typically go back to another restaurant and try to have your food there. But doing this has certain problems. That is, even though the hotel told you that there's a free breakfast, because of these uncomfortableness or because of these issues, you're going out and then you are trying to spend some money for that. So there is some extra money that you have to spend. And not just that. Now, typically, when I say if you're going out for a vacation, we would have planned, right? So let's assume that we would have planned in such a way that we'll go to the restaurant at 8 o'clock, have our food, and then start from 8:30, and then we will begin our sightseeing by 9 o'clock. So this is how you would have planned your day. Now, what happens here when you find out that the restaurant is going to serve both kind of foods? Then if you start searching outside, you will not be getting the right place for you, right? Or the right restaurant which will fit everyone in the family. Now then the problem happens is you're spending time and money both, correct? So this is one of the problem that we will be facing. Now, how is it related to us technically? Now, replace the same scenario where instead of a hotel, now you replace the hotel with a server and replace all the users, like how we had people staying in a hotel, you can replace them with an application. So now what happens? In the same machine, you will be having many applications running. But for that to run, you will be having specific hard disk in which you're going to install them, and there will be a specific amount of RAM that it will be using. But that will be using it until you have the application running on them. Now, the concern that we would have is there will be certain libraries that is available on the machine, which has to be used by different applications at the same time. So in those cases, there will be some concerns in running the application. Now to understand it, let's take example of a Java application which needs Java 1.7, and there is another Java application which needs Java 1.8. Now, I will not have a concern in installing Java 1.7 and 1.8 on the same machine. But if I try to run both these applications, which is Java 1.7 based and 1.8 based together, then if they are trying to share the libraries, that is where we will be having the concerns, right? So now, just like the restaurant problem, what is that you're going to do here? Even though you have a machine which has huge amount of hard disk and RAM which is left over, still you will not be able to run. So this is where you will be going ahead and you will be trying to get a new machine, and then you will try to set up whatever that you need for your environment and you will start your work. So here what happens, it's the same problem of the restaurant that I said. You have to spend time in trying to get a new machine and set up the environment, as well as it is going to incur some cost, right? So now this is the problem that we will be facing in a day-to-day life. So whether I'm a developer or a QA, if I have certain requirements like this where I have to run different applications, it's not possible that I can run all of them in the same machine. Regardless of the hard disk and RAM, there will be a lot of other dependencies and libraries which will not be able to share. So that is where we will be going with different machines. So now when you think of taking different machines, it is going to take a lot of process, time, and money involved in it, right? So this is one of the concern that we have. Now, another well-known problem. So if you understand, this is what we call it as a firefighting between a developer and a QA. Now, ideally what happens is when a software development lifecycle is going on, developers will write some kind of code and they will do a unit testing in the machine which they are developing, and then they share the code or the application to the QA for functional testing. Now what happens? Many times the code whatever the developer has written and used for unit testing will work in his machine, but now the same code or the application, when QA is trying to run on that or on a deployment or a production machine, it might not be working. Now the problem is the application is same, but what is different? So this is where there could be many differences. There could be a problem in the OS or the specific version of OS what they have taken, or supporting it there might be some libraries which are not same, or some kind of dependency files are not there or missing, correct? So that is where now what will happen, developer will say that, hey, I did the testing, it worked in my machine, so it's fine. So that's the reason I went in and checked the code, or I submitted the code. But QA will say that regardless of how it ran in your machine, if it doesn't run in my machine or on the environment where you want to test it, we will not be agreeing. So that is where the problem here is not the code, but the problem here is the environment. So this is where when I say environment, it's all about some kind of OS files which is needed, and along with that some kind of libraries or some applications or binaries that you need to do your development or testing work. So this is the user concern where how do I make sure that whatever you have in your development environment is the same, which you can also share it to QA to test, and if possible, you can share the same to also to a production environment or a customer where they can simply take it, start using your application. Okay, so these are the problems that we have. So now, if you understand, from a developer, he needs to make sure that whatever the environment that he's developing, we should be able to share the same environment to QA, and also from QA we should be able to put it into the production. So we need to make sure we have the same environment across everywhere. Okay, so again, I'm not worried about the machine, I'm more focused about the environment. So when I say environment, I'm talking about the OS files or the OS environment that I need, plus whatever the libraries, applications and binaries all together is what we call it as a environment. Now other than that, if you talk about a developer, what happens is sometimes he might be using different machines. So now he should not be worried whether he is given a Windows machine or whether he is given a Mac or a Linux. He should be able to do the same work on all of them without much difficulties. So how do you make sure that whatever the work that you have again can be done in the same way across different machines? For this, once again, what you need is an environment. Okay, so that is where for a developer, whatever the work that he's going to do should be easy to do the porting, because today he might be using a machine, tomorrow if he goes to another machine, he should be able to get the same environment on that machine and you should be able to start your work easily. Okay, and now when you talk about QA, for some kind of load testing or performance testing, let's assume I want to make 5 copies of my application and then run. Now, if I say this, I cannot take 5 separate machines and make sure the same environment is available on all those 5 machines, which should be exactly the same. Then, if I do this, then once again, it is going to take a lot of time and resources to set it up. Okay, so now if you understand, as we are moving towards the CI/CD world where we need to do the development and testing continuously and deliver continuously, we should be able to bring up an environment which we will be using it for development or testing or deployment to be faster. So how is that you're going to get, which is the biggest concern that we have in terms of SDLC. Okay, now a solution for this will be virtualization. Now, virtualization is not something new, which has been there even from a longer time. But the problem that happens is if an administrator is giving a solution by using virtualization or something like VMware, the problem is performance. Because if you have noted, when you install a tool like VMware on your laptop or some other machine, it takes up too much of resources for itself, right? So that's where if you install it on your laptop itself will become slow. So that way, you need to add more and more resources for that to run. So now when you say more resources, it is going to take more cost for that. So that is where one of the concerns that we have using VMware or virtualization is performance and cost. And not just that, when we talk about CI/CD, we need everything faster. It is not that if I say VMware, if I have a VM, if I want to replicate it, it will also take at least 15 to 20 minutes for me. So that is when for a developer or a QA, if they want to do some test which will take 5 minutes, you are going to spend 15 to 20 minutes only to create an environment. Okay, so from a higher level, if you understand, it's not just that a developer wants to share the same environment or the QA wants to take the same environment and make multiple copies of it. We also need to make sure that we have all these things done in a faster way and also in a cost effective way. Okay, so this is what is the big concerns that we have. Now, how do we solve this? Okay, so now to understand a solution is containers. Okay, So now, once again, we need to understand what exactly is a container and how does it solve all the problems that we were talking about some time back. Okay, so to understand it, first let's understand the basic terminology of containers. Okay, now when I say containers, what will come to our mind? Now, typically the first thing that when we say container, the shipping containers comes into our mind, right? Because when I say containers, most of us will be thinking of only that. So now, in general, if you say container, containers are nothing but empty box. Okay. Now, what is it? So containers are empty box in which you are going to put whatever that you need, and whatever that you put inside the container will be kind of sealed, or what we call it as capsuled. It will not be mixing with one another. Now, this is why they used it for shipping industry. Now, to understand this, let's take another example in it. Now, let's say that I have a ship which can carry 10 tons of capacity, and if I want to transport something, now in that, if someone comes to me and says that, hey, I will give you 5 tons of raw material and I will give you 5 tons of fish. Now, I cannot carry fish directly. So what I need to do, I need to have some kind of cold storage so that I can put those fish. Now, if the person comes to me for the first time and he gave me 5 tons of fish, so probably I'll make half the ship as cold storage and I can put the fish and raw materials side by side and I can take it up. But what happens after some time, the same person might come up and give me either 3 tons of fish, or he can give me entirely 10 tons of fish by himself. Now, this is where, how will I make sure my business is running fine? So I cannot make my entire ship as cold storage, right? Because if I do that, the problem is, if I do not get fish alone and if I get something else, I will not be putting that into my cold storage, correct? So that is when they came up with the solution, which is containers. So now if you match with what I said, so containers are like empty boxes. So you fill whatever that you want inside and it will be only inside it. So this way, now assume that each container is 1 ton capacity. So what I can do in my transport, now if someone comes with 5 tons of fish, I will take 5 boxes, which is cold storage, and I can go ahead and I'll be able to put the fish inside it. And along with that, I can take different containers and put whatever the raw materials that I want. So this way, what will happen? I'll be able to take everything together, okay, and one top of the other. So now containers will solve my problem. So if someone comes up with only 3 tons of fish, then I will take 7 empty boxes. So I'll take 7 empty boxes. I will put some kind of raw materials and I will take 3 boxes which will have the cold storage. So depending on my need, I can take as many cold storage boxes or remaining empty boxes in which I can put some kind of raw material. Okay. Now, this way I can carry one box on top of the other.
Madam,
Now,
could you repeat that again? Sorry.
okay. So what I was trying to tell is, so now if you say in the shipping industry, I can take several containers in which I can take a container, make it cold storage and put meat or fish, whatever I need, as well as I can take several other containers, put whatever the raw materials I want, and I can carry everything together. So that way, there will be no concerns for me. So if someone comes and gives me 5 tons of meat, then I can take 5 boxes and make that 5 boxes alone as cold storage, and remaining I can take another 5 boxes or containers and put whatever the raw materials or whatever I get, and then we can ship everything together. So this way, my shipping problem will be solved. So that is where the basic understanding of containers is, it is nothing but an empty box in which You put whatever that you want inside it, and it will be capsuled, and it will not be mixing with one another. And you can carry as many boxes that you want depending on your need, one on top of the other, and it will not be mixing together. Okay, so this is how containers are going to help to solve the problem in shipping industry. Now, let's take another common example of containers is our lunch boxes. Okay, or at home you would be using containers, right? So that way, what is the meaning? So now let's assume that I want to carry lunch. Now I want to carry rice, and I want to carry some bread, and I also want to carry some curd. Now typically I cannot put everything into one box. So the solution for that, what do? We create containers and put into it, right? So now for my lunch, I would carry 3 containers or 3 boxes, which is encapsulated. So I will take one box, put rice, and I'll take one box and I will try to put my bread, and I'll take another box or container and I will put curd. And this way I can carry everything together. Okay. So this is how to solve your day-to-day work, whether it's the lunchbox or even at your home. A container is nothing but a box in which, guys, can you please go on mute? Okay, so what you will do is you are going to take an empty box, put whatever that you want, and kind of close so that it becomes a environment which is enclosed, or it is kind of capsuled. So this way, I'll be able to carry my lunch and nothing will be mixing together. Okay. Now, with this, let's get into the technical side. Now, what exactly is a container? So now, as I said, you have to think of containers in our real-time world as a process, because when you go to your machine, everything is a process. But what kind of process? It's a process which is created virtually or using some kind of OS virtualization. Okay, so that way, now inside your machine, you can think of a box and put all those things that you needed, just like your lunch. Instead of taking everything together, or if you go back to our actual problem that I was saying, wherein we have a machine in which you're going to install all the applications and run, right? Wherein if I have a Java 1.7 for that and a Java 1.8 for this, all of them will be sharing the same libraries, which is the problem. So now, if you consider that as a solution through containers, so containers are nothing but empty boxes, but technically it's not a box, but it is a process which is created virtually. So now, what is that you're going to do? So inside this box, put whatever is needed for your environment. So that way, put some applications or libraries that is needed specifically to you and start running. So this way, to go back to this problem, what I can do now is, if I have a requirement to solve, I can create a container and put my first application and install Java 1.7 in it, and it will be remaining only inside the box. Same way, I can create another container which is like an empty box, and inside that I can put my application which is dependent on Java 1.8 in this. So this is how on the same machine I can create as many boxes or containers that I want, and I can put all those things which are needed specific to my work or the environment. So this way, anything that you put inside a container or this box will not be mixing with each other. And at the same time, both the containers will be running on your machine. So just like how in a lunch bag or in a shipping industry, you can keep one containers on top of the other and you can transport or carry, the same way, in the same machine, you can have multiple containers and you're going to put all those things that is needed for your environment to work inside it, and this will not be mixing. Okay, so this is how containers is going to solve all the problems that we are talking about. So this way, on the same machine, I can have multiple containers and inside each containers I can have specific environment that I want, and that will not be mixing with another container. So anything that you put inside a container will remain inside the container. Okay, so that is how you will be able to solve this problem. And not just that, it will be easy for us to share the same environment to others, or we can make multiple copies of this environment in an easier way. Okay, so that is what we are going to understand technically little later. But for now, to go back, so container are nothing but a process which is created virtually, and like I said, it will be empty in the beginning, but what makes it meaningful is you need to put whatever the environment that you need inside it. So that way it will be acting like an environment in which you will have all those things which is needed, and you will be able to do all the work without mixing it with others. Okay, so in this, when I say container, it is nothing but a process which is created virtually. So that way, for running some application inside this container, the hard disk and the RAM, whatever that you need, will be shared from the host machine. Just like your regular virtualization or VMware, if you create a machine, the hard disk and RAM will be given from the host machine, right? The same way, the containers will also take up the hard disk and RAM from the host machine. But specifically inside each box or the container, you are going to have your own environment. So when I say environment, you can have some specific OS files that you need. You can have a specific libraries, applications, and binaries as per your need. So this is where now I can have a host machine which is of Ubuntu. But if I want to work for my application, if I need CentOS, then I can take CentOS related OS files, and typically I will take all the libraries and applications for my need, and I can start working. So this way, for another requirement, let's say that I need Red Hat. Now on the same Ubuntu machine, I can take an empty container and I can put the Red Hat related OS files and all the libraries and application required for my work, and I can start doing the work. So this way, on the same machine, I can have multiple containers available, and it will not be mixing with each other. So this way, it gives us the freedom, and it is very easy for us to create this container, as well as it will be easy for us to make copy or share it. Okay. So now if you go back and try to see how does it solve all the problem. So now if I'm a developer or a QA, I can easily create a container, put whatever the environment that I want. When I say environment, these are the things, and it will make sure that whatever I do inside the container remains inside the container as files. Okay. And going back to a little more basics. So now the question comes is, how many containers can I create? Now, typically it goes back with the same problem, or let me say the same lunch bag. Now, if my question to you is, hey, how many containers can you carry for your lunch? Now, it sounds stupid, but if you understand, it is not the number of boxes that you can carry in your lunch, right? Because if you take a dabbawala, he'll be carrying 30, 40 boxes, right? So it's all about the need. And what's important here is, it is again not the number of boxes, it is what is the content that you're going to have inside the box and what is the weight of that. So let's assume I can carry 10 kgs with me. I can carry one box, and inside it I can put something of 10 kilos, or I can take 10 small boxes and each one of them can put or can take up to 1 kilo. So that way, it is not the number of boxes that I can carry, but what is the total weight I'm carrying inside it. The same way, if you look, to create a container, it doesn't take much of the resource. So that way, it's just like an empty box, like how you have your empty tiffin. Here, if you say container, these are empty boxes. Now, only when you put your environment inside it and you are going to run your application, it is going to take the resources. And that too, containers are going to take the resources from your host machine. So it is as equivalent on running your application directly on the machine, because container is on your machine and anything you run inside the container is also running on your machine. But the difference is, instead of running directly like earlier, you're creating some kind of enclosed layer, and inside that you're trying to run. So that gives you the freedom. So that is where it is not about how many containers you can create, but what is running inside the container. So if my host machine, for example, let's assume that my host machine has 10 GB of RAM. Okay. And now if I want to run one application and each application takes 4 GB, then what will happen? When I take two containers, when I run it, each one of them will take 4 GB. So now that is going to take from your host machine. So whatever it is taking will be from the host machine. So now if I go back and see, once the two containers are running and application is running, you will be left over with 2 GB of RAM in the host machine. So now can I create another container and run another similar application? It will not be possible, because you can create a container because it's like an empty box, but an empty box doesn't make a meaning, because a box is nothing but here a process. So I cannot have an empty process. But to make this more meaningful, you need to put the environment and run the application. But to run the application, I do not have sufficient RAM. So that is how it is not about creating how many containers that you want, but it's typically what is it going to run inside the machine, and does the host machine has enough resources to help you create container. Okay, is that clear first on what is the problem that we are trying to understand in terms of how do we make sure we
Yes.
create environment, and
Yes.
what
Yes,
is
Adam.
basically a container?
Yeah, yeah, Adam.
Any questions before I jump into the next topic? Is it clear to everyone on what exactly is a container?
Yeah.
Hi
I have
Adam.
one, I have one question, Adam.
Yeah, please go ahead.
Adam?
Like how the processor is gonna read if you have uh, tools encapsulated in two different containers? The processor has to take everything into one account, right?
Yes. So
Or
here, if you understand,
do you guide that to run within that container?
yeah. So that is where we need a tool which will do all those things. Okay. So we'll get into the deeper side of that. But to quickly answer you, if you understand what you are going to have inside the container is only this. However, the kernel, whatever that you need, which will be scheduling the process, will be taken from the host machine. So typically, how are you going to create the container? So that's when we need a tool. So that will communicate to the kernel of the host machine and get all the process done.
Oh, okay.
Okay, which will support it later.
Yeah, thank you.
Adam, I had a
One
question.
quick question.
Yeah, go ahead.
Can this Dockers be hosted directly on the server hardware, or it need a
You,
supporting OS?
you can do it on a bare metal. Yes. But
Okay,
typically that's what we'll come into those part little later. But what I want you to understand here is that what is the meaning of container and how is it going to solve? Okay.
okay, fine.
Hello, hello.
Yeah,
Hi,
Adam,
Adam.
I have a quick question.
Yes. Yeah, go ahead.
Shall I go ahead? Okay. So we have two machines on screen. One is the host machine with the traditional way of hosting the applications on it, and the right one is with the container. So my question is to help protect the applications run as expected, the vulnerabilities that the traditional way host machine has, this even though we host the applications in containerized environment, even those applications will have the same vulnerabilities inherited, right?
Exactly. I got the point. I'll get the answer for you in the next slide. So as I said,
I'm
we
sorry if I'm
haven't gone
asking
into
the
the
right question.
No, that's the right question. I'll answer you the same. But as I said, for now, I want you to first understand what is container so that we will jump on to the next topic on what is Docker and how is it going to help you further. Okay.
Hi, Adam.
Sure. Thank you.
Yes.
My question is, how many OS can we install inside a container? And can we install Windows as well as Linux in a container?
Okay. That's a good question. So now, again, I'll be talking about this a little later, but to talk about it quickly, you can have only one OS at any point of time. Okay. However, it's not like you're going to have multiple OSs. All of them will be taking from the host machine. So your host machine can have a different OS, and each container will have one OS in it. Okay. And what kind of OS? It supports all the OS. So I'll talk about those little detail on what is your environment. Okay.
Okay, thank you.
Yeah.
Hey Adam, this container process is some sort of virtual thing, right?
Yes.
So like, what is the difference here in virtualization and the containerization then?
Okay,
Is it
guys,
same or what?
all of us are jumping ahead of the question because if you go back to the agenda, that is what I said. Now I'll answer all the questions that you have. But before
Okay.
that, I want you to first understand what is the meaning of container and how is it going to solve. Okay, so that is what I was just trying to stop. So now let me go ahead with the other things as you were asking, and you will have all the questions answered. Okay.
Okay.
So now at least we know that. So when I say container, it's nothing but a process which is created virtually. So you should start imagining an empty box, and inside that you will not have anything. So you need to put an environment, wherein when I say environment, you're going to put some kind of OS files, libraries or binaries or applications that is needed, and you will have your own environment, and that will not be mixing with another environment or another container. So this way, container is a technology. Okay, now how do you exactly get that? So that's where there are many tools available in the market which will help us to create containers. Okay, so now coming back, so in order for you to work on this container based technology, you need to have some tools. Okay, so there are many tools available in the market. Now one of the popular tool which is available in the market to help you in managing or creating the containers needed is what we call it as Docker. Okay, so now we don't tell Docker as the tool because there are many things that you can do. So going back to the agenda that I was telling, you can typically do a container management, you can do image management, as well as later on as we move on, we can also do orchestration. So that is where we call Docker as a platform. So using this, what you can do now, typically you can create containers which can be used for development, and the same thing can also be given to QA people, or we can also give it to the customers for deployment. Okay, so typically Docker is a platform which helps us to manage containers, and internally Docker uses the open source container technology. Okay, so that is where Docker become popular. So people still don't understand the basic. That is the reason first I wanted to tell you what exactly is a container. So if you understand now, Docker is a tool which helps you to create containers. Okay, now how does Docker do all those things? So Docker again internally uses a OS level virtualization. Okay, and now comes the question is that, okay, so if you say that if I want to do all those things like containers creating and working or sharing, then what I need is Docker. So where I can install Docker? So that's where you can install Docker anywhere. So it could be a bare metal or a physical machine, or it could be also a virtual machine. Like you already have a VM, you can go inside the VM and install Docker and create containers on it. Or on the latest way, you can also go to cloud, whether it is AWS or Azure or Google Cloud, you can take a machine and install Docker on that. So regardless of what kind of machine that you're taking, using Docker, you will be able to create this container on them. Okay. Then you can run anything inside a container. Okay. But the difference here is, if you understand, your container is going to run on the machine in which you have installed Docker. So that way, for example, if I have installed Docker on my machine, and if I am going to create container, then whatever I am going to run inside the container is actually running on my machine, because your container is running on this machine. So that is where anything that you can do on your host machine, it is the same thing is what you're going to do inside your container also. If there is something which is not possible on your host machine, then you cannot do that on your container, because the basic is container is nothing but a empty or a box which is created virtually. But where is it created and running? It is running on your host machine, and it's going to utilize your host machine's resources only. Okay.
Adam, can you give us a quick example of what we cannot do on the host machine, we cannot do it on the container? An example.
Okay. An example that I say, that if there's a security violation wherein, let's assume that you cannot access a particular port from your host machine, the same is also will not be able to access on your container also, because underlying whatever you're going to run an application inside the container, it is going to honestly run it on the host machine on the other way. So whatever the communication that you're going to do outside, right? Now let's assume that you want to connect to your database from your application. Now the route that you see, it is going to the host machine, and from the host machine you will be able to connect to database or some other machine. But if your host machine is not allowed to communicate to another machine or a database, then if a container is running on your machine, it is the same that from your container also you will not be able to do or access anything. So that's what, in simple, if there is something that you are doing which is possible on your host machine, the same thing is also possible on the application inside the container. Okay.
So in that case, for example, if a database server is supposed to receive connections only from Linux machines and not from Windows machines, and assuming I have a host machine, Windows, on which Docker is installed and a container with a Linux machine is there, can that not container contact the database as designed, as supposed to be?
Exactly. So now, regardless of the OS or the files that you're taking, if your host machine doesn't allow you to connect directly from that machine, obviously you cannot do the same thing inside a container. Okay.
All right.
Okay. Now,
Hey Adam, can we SSH or RDP containers like host machines?
can you repeat the question?
Sure. 1 second. Can I SSH or RDP containers like host machines?
Yes, you can do it. So there are certain connection settings that you have to do, but yes, you can do that.
Thank you.
Okay. Now again, I'll ask a couple of things.
Actually,
Yes, go ahead.
what is the VM and container? Actually, it's like similar properties like a VM and container is having. Can we scale up like storage extend and RAM extend for Docker also?
Okay, I'll talk about it in the next slide when we have the difference between containers and VMs. Okay.
Sure, sure, thank you.
So now, as I was saying, so Docker is nothing but a tool using which you can manage containers. And you're going to typically take a machine, install Docker, and using Docker, you're going to create the processes, which is what we call it as container. Now, the major reason why Docker got so popular is it's lightweight. Now, compared to VMware, if you install VMware, like I said, on your host machine, performance will come down. But the same thing, if you're trying to do or work with Docker, it will be quite lightweight. And it doesn't take RAM for creating containers. Okay, typically when you're creating the container for the first time, it's going to be empty. So that is where, when you say empty, there is nothing running. So that is where for creating a container, you don't need to allocate any RAM. Only when you start running something inside the application, then you are going to have some RAM allocated. Okay, now to understand this, let's take up the difference between a VM and a container. Okay. Now, going forward, when you say container, it's nothing but Docker, or when I say Docker, it's nothing but a tool used for creating container. Okay. But ideally, what you are creating is a container using a tool called Docker. Now, when you take this VMs, what is that going to happen is you will take a host machine and then you will install some kind of hypervisor like VMware, and using that you will be creating machines, which is called as virtual machines. Now, when you create, see, even when you are buying a new laptop, what happens is, let's assume that you bought a laptop wherein you wanted to have 24 GB of RAM. But as soon as you switch on your laptop, you will see some 700 or 800 MB of RAM is already gone, right? So who has taken it? So typically the OS that you have installed on that machine is going to consume that, right? The same way, now what happens is, when you say that, let's assume that we take a machine and I have around 12 GB of RAM on my host machine. If I install some OS, typically it is going to take some RAM. So roughly, let's say that 1 GB of RAM is given to the host machine itself. So remaining is 11 GB. And now when you're going to install some tool like VMware, that will also take another amount of RAM. So let's take another 1 GB of RAM. And then when you are going to create a VM, each of the VM will have its own OS installed in it. So because of that, what will happen is you are going to dedicate some RAM for the OS which is available inside it. So that is where in the regular or the traditional virtualization concept like VMware, just for creating a VM, you are going to allocate some RAM. The same way like your laptop, whether you are using it or not, some RAM is given to the OS that you have installed, right? So this is how, when you take in this example, without doing anything, you will be spending minimum of 3 to 4 GB of RAM just for creating virtual machines, which is why the problem is that as soon as you create a VM, you need to allocate some RAM. And then as you start running the VM and running some applications inside it, it is going to share further RAM from the host machine. This is the typical or the traditional way. Now, but what happens in containers? Now, unlike the regular hypervisors like VMware, Docker is lightweight. So it is not going to take too much of RAM. That is one. And the next thing, if you understand, when you say a container, it's nothing but an empty box. So that way, for creating an empty box, it doesn't have to create any RAM, because virtually when you are trying to work, only when you have some kind of application inside it and running, only then it is going to consume the RAM or the resources from the host machine. Okay, so this is where now for creating a container, you do not have to allocate a RAM. Only when something is running inside the container, it is going to consume the resources from the host machine. So that is what the point that I was mentioning, that you don't have to allocate any RAM. So that is where the question that even I was trying to answer earlier is, you can have as many containers created, but what matters is how much of applications that you can run depends on what is the total resources available on your host machine. Okay, so this is the typical difference, because of which it is going to be lightweight and easy for us to work. Now in this, when you create a container, by default, a container can consume all the resources available on the host machine. Now, for example, if I have only one container, that same container can also consume all the 12 GB of RAM from the host machine, because it is just like, instead of the container box, if you were running the application directly on the host machine, it can consume all the resources, right? The same way, if you create a container, by default, it will allow to use all the resources that is available on a host machine. This is the default behavior. So that way, when you have more containers, the total amount of resources that is being shared by this container will be equal to or lesser than what you have inside your host machine, because it cannot be higher than the host machine. What do you mean by that? Now let's assume I have 12 GB. Now to run one application, let's say you created one container and this container took up 5 GB of RAM. Then when you create another container, how much will be left for this container? Whatever is available on the host machine. So if the host machine is left with 7 GB, this container will take 7 GB. Okay, but it is not that you are giving 7 GB to this container. 7 GB is available for the applications to run inside the container. So that way, how much ever the application uses in this container, it will be taking from the host machine. So let's say another application run for 5 GB. So now on the host machine, 2 GB is left over. So now when you create a third container, what will be available inside the third container is whatever is available on the host machine. So that way, this will be left over with 2 GB. So that way, the total sum of the resources that you're using should be always equal to the host machine or lesser than that. Okay. Now,
So,
the default
Adam, a quick
behavior is,
question. I'm sorry.
yes.
You're telling us that whatever resources are there on the host machine, memory and other hardware, whatever that is. So basically, the host doesn't have any control on what or how much resources a container can use. So
That's what
is
I
that
was
correct?
trying to answer. I'll answer you
So
that.
in that,
I was about.
Oh, I'm sorry. In that case, should there be, like, for example, a scenario wherein we have 5 containers running 5 different applications, and knowing that the host machine doesn't have any control on how much resources the containers can use, should an application go rogue and try to use more application? Does that not create a kind of impact on other containers?
Okay, I'm
Is
sorry
that a
to
good
cut.
thing?
That is.
I mean, my question is, I'm sorry, is that a good thing to let the containers use seamlessly all the resources on a host machine? Should the host shouldn't have a limit set of how much a container can use? Should they start behaving rogue and disturb other containers?
Lakshmikant, that's actually the right question, and that was the next sentence that I was about to tell. Okay, so
Oh,
the
I'm so
answer for
sorry.
you is again, yeah, problem. So yeah, I was telling the same. So the default behavior of a container is, it is going to allow everything that is available on the host machine. That is the default behavior. But however, Docker gives us the ability where, when you are creating the container, if you do not tell anything, it will try to use everything that is available on the host machine. However, depending on our need, we can also put a constraint on what is the maximum resource that each container should be using. Because now let's say that I have a requirement in which I want to make sure for my application I need 5 GB. Then while creating a container, I can tell to Docker that, hey, help me to create a container in which the maximum capacity or the resource that it should be using is this much of GB of RAM. So that is 5 GB of RAM or whatever CPU that you're going to give. So that way, by giving a constraint, when you start running the application will still get whatever is available on the host machine. But when it starts running, when it reaches the limitation or the constraint which is being defined by the Docker, So Docker will have a control and will say that, hey, now you have reached the limitation of 5 GB RAM, so I'll not allow you to use anything more. So that is how you can have a control on how much the resource that each container is going to use through Docker. But again, I'll repeat it. It is not that you are allocating 5 GB or whatever the GB of RAM from the host machine. You are not taking it away. Everything will be available on the host machine. It all happens during runtime. When it is running, it will be using the content from the host machine. In that way, the maximum it can go is 5 GB. So that is where still when you create a container, you are not allocating anything. You are just putting a constraint. If an application is going to run inside the container, the maximum that it should use is 5 GB or whatever is your requirement. So this is containers is that Docker will allow everything. But if you need through Docker, you're going to put a constraint by saying what is the maximum resource that in terms of CPU or in terms of RAM it is going to use. Okay, so that's the difference. Yep. So most of the questions I'll be answering it. So that's the reason I said
Yeah,
if you can
Viraj,
just
I
wait
have
for
one doubt. Avinash,
yes, sir.
I have one doubt. See, I have a 12 GB of RAM. I am installing container like Redshift and MySQL MariaDB. So it automatically allocated the space whether we want to allocate the memory like that. See, if I'm
It is not
installing the
yes.
certain,
Now what is the
it
question?
automatically allocates whether we want to allocate. See, actually, we have 12 GB RAM server, 12 GB server for that. Okay, I'm installing the Redshift and OpenShift and MySQL MariaDB for that. Okay, how the RAM will be calculated from different platform. Okay, whether
Okay,
each
see, I
an
think
application will take 1 GB like that.
no. See, you're not understanding the basics again. That's the reason I was explaining you. See, container is nothing but an empty box. Now forget container. Now, if you are going to install MariaDB or whatever database on your host machine, how much of RAM does it need? It is the same that when you put inside the container, it will be taking. Okay, so there is no change in the application on how much it is going to use for the application to run. But the difference, what I am saying is, when you install an application directly on the machine, it can consume everything which is available. But when you put inside a container, you have
Okay.
the default ability where if you do not tell anything, the application will go and take everything directly. But using Docker, you can tell that when the application is running, what is the maximum that this container can take. So that way you can control the application to make sure that it doesn't use beyond some resources through the container. So that way, now for example, if I have two containers or let's say three containers created, and let's say in three containers, for each container I will say 33 GB or 44 GB, let's assume. So now what will happen? I can create three containers in which I am specifying the limit as 4 GB, but it doesn't mean that 4 GB is given directly. But when the application start running in these containers separately, the maximum that each application can consume through this container will be 4 GB. Okay, so it is not the restriction. So whatever that you were running so far on the machine directly as an application is what you are going to do again inside the container. So there is no difference in running container, but the only difference is when you directly run the application on the host, it will take, or it has the ability to take everything. But through container, you can put a constraint saying that the maximum that you're going to use is a particular amount. So that way you are not allocating anything to the application, but you are limiting on what is the maximum that it can use. Getting it?
Okay, okay, thank you. Yeah. Thank you.
Adam, I had a question.
Yes.
See, you told that we can put a constraint of RAM on container. So if the application sometimes will take beyond that RAM, the allocated, will the application get crashed?
Yes, it will fail. Typically your container will get stopped. Okay, so that is where it's a whole other logic that we need to understand. But yes, so this is where you need to know what is the capacity that is needed for your particular application. So based on that, when you create a container, you need to set up the constraint on how much it is going to use.
Okay, it's basically the application developer who decides how much GB need to be allocated.
Yes, let me not say developer, whoever is going to use the application inside the container, they should be aware of what is the resource constraint that you should be giving.
Because I asked this question because SQL application usually occupies how much over the RAM you allocate.
It's the same regardless of what application you're running, because for some application you can tell the memory, but if not, whether it is database or anything. Now in your example, if you install a database like MySQL on a machine directly, it can take everything. But using a container, if I say the maximum that MySQL should be taking is 12 GB, it's not from the application. You are setting up from the container. So when the MySQL inside the container start running and it starts using it, then when it reaches the maximum constraint that you have given in the container, then it is going to stop, or the container itself is going to stop. Okay, so that is where it's quite important for us to know what is that you're going to run inside the container and how much of the resources should be limited.
Adam, in the
Thanks.
containers, for each app, there will be a different OS, right? So if to install different OS, again, we need some more RAM, right?
No, I'll talk about the internals that's on the coming up slides. But for now, try to understand the difference. I'll answer the
But
question.
in this slide, we are not shown any OS related things in this app 1, app 2, app 3, right? So I just want to.
I'll talk about those internally. That's what. See, I'm just going phase by phase. Everything is not possible to talk in the first slide. So that is where I'm talking more
Okay,
from,
yeah.
if you understand, you know what is container. Now you know what is Docker and what's the difference. And then we will get into the components or the internals. So that is what will answer your question. Okay.
One quick question, Adam.
Yes.
So when we set the limit for a container to reach maximum only this much amount of RAM, and for example, if we have a scenario here with the 12 GB is what the host machine has, and if I allocate 44 GB, we cannot do 44 GB. For example, if we have 2 GB is allocated for 3 of these containers, so 6 GB is what the Docker, all the containers will be using. If I check the hardware status of the host machine, how much RAM will I see?
So this is where, if you take a real-time scenario, 6 GB should be taken, plus the host machine also has a OS which will take some RAM, plus Docker, and there might be some other applications running on your host machine, right? So you need to consider the consumption of that. So typically you can say another 1 to 2 GB will be gone. So typically some 8 GB roughly will be gone. The remaining is what you're going to have.
Okay, in that case, for example, 2 GB is set to container 1, application 1, and I can see the status of the container that it is just using around 1 GB of it, but the maximum range is set to 2 GBs. And
yes.
Same happens with all the 3 cases, 3 containers. So 6 GB shows as occupied in the hardware status of the host machine, or it just shows. So you're not reserving RAM basically.
That's what the whole point I'm trying to repeat it. You are not allocating, you are defining. See, that way you can create 3 containers. For each, you are saying maximum is 2 GB. But it doesn't mean that as soon as you create 3 containers, if you go, whatever that you have total minus 6 will be available. But it depends on how much it is using. Suppose each container is using only 1 GB, then what you will be seeing is total RAM available minus 3 GB. That is how it will be. So please remember, you are not allocating any RAM. Only when you start running, what is the maximum that each container should allow is what you are going to tell.
Understood. Thank you.
One quick question. Out of 3 containers, 1 container crosses its limit, so it will crash, right?
Yes.
Yeah, in the so it crashed. That is fine. What about remaining? Will it impact remaining containers also? Say,
See,
I mean,
again,
out
you're
of 3 containers, 2 will be running. Okay, and one container crossed the limit, so it crashed. So will it impact other containers?
it will not impact. See, this is where you need to understand what is the total capacity you have, and you are going to allocate the resource needed for each container. Now, just because one container is trying to use too much beyond the limit what is given, or I would not say container, I would say the application inside the container is trying to use the resources beyond, so the application will get crashed. Obviously, the container will get crashed. But now, if you come back here to run these two, do you have sufficient RAM available inside it? Yes, if it is available, it will be still running. So it doesn't mean that if this application get crashed, all the other containers will get crashed, because it has the enough RAM. So it all goes back to the basics is whatever is available on your host machine, you're going to take that and use it. Getting it?
So it's a best practice to always set a limit to the containers.
Exactly. That's right. Okay. Now, guys, just wait for a few minutes so that I'll just finish off the topic, and I'll be happy to take all your question and answers, because if not, the session is going to be too long. Okay. Just give me a few minutes.
Adam.
Yes.
Hello, Adam. Actually, I want to say one point, Adam, to everyone, because everyone asking the memory CPU utilization of container limitation, right? So with your permission, can I share one snippet? Because everyone
Hari,
will get the clear clarity.
Hari, sorry to stop you. I'll be happy that if you can wait for another 5 minutes, I'll be done with this. Then we'll have a complete question and sessions. Okay.
Sure,
Not,
Adam. Welcome.
Yeah, I appreciate it. Thank you.
Go ahead.
Yeah. Okay. Because a lot of things which will be answering your questions. Anyway, now to move ahead. Now, I was talking so far from the topic of what is Docker, container, right? Now let's understand what are the components of Docker. Now this is where we need to know how exactly the internals of Docker works, so that it's quite easy to correlate all these things that I'm saying. So now when you take a machine and when you say you are installing Docker on it, okay, now that machine is what we call it as Docker host. So any machine that you take, like I said, a physical machine or a virtual machine or a machine on the cloud, if you try to install Docker, then it is called as Docker host. Now, as soon as you install Docker, what you are going to get is two components of it. Okay, so these are what we call it as core components. So when you install Docker, again, I will tell there are two parts that you will be getting in it. One is called as the daemon. The other one is called as the client. So the daemon is a process which will be running on the machine, and this is the one which is going to do all the work for you. And when I say daemon, in Linux, the basic meaning of a daemon process is a process which runs in the background without any user interaction. So that is where if you want to do any work on this machine, you cannot directly interact to it. So in order for us to interact, we will be using the client, which is what is the command line which we will be entering. So typically now in our day-to-day work, we are going to use the command line utility, which will be communicating to the daemon and get the things done with whatever that we need. Okay, so remember, in each and every machine when you install Docker, you're going to get a Docker daemon, which is a process which will be running on the background and which is the main process which does everything. But in order for us to communicate to it, we will be using the Docker command line utility, which will be helping us to give the commands and pass it to the Docker daemon. Now, when you consider the overall Docker workflow, it will be somewhat similar to Git workflow. Now, don't get confused with Git and Docker, but from a overall, if you say Git, how do you work? Now, if you are a developer, there will be a central repository in which your code will be available. So when you want to start your work, you are going to make a clone of that central repository to your machine, do some changes, and then when you want to share it back to everyone, you're going to put it back to the central repository, right? So somewhat similar is what we are going to do. So that way, when you're actually working in Docker, now I was talking only about the component called container, but as some of the questions that were coming in between, how will you get the environment that you need, right? Because container, like I said, is an empty box. How are you going to get the environment that you need? In the sense, how will you get a specific type of OS files or libraries inside that container? So that you are going to get through something which is called as an image. Okay, so I'll talk about image in the later slide, but for now, what you need to know is image is a component which will have whatever the OS files, applications, or libraries that you need. So using that only, we will be able to create it as a container. If not, in the simple way of explaining, container is like an empty box. You take an image and put it inside, then it becomes an environment for you. So that way, when you install Docker, you are not going to get anything on your machine. So you need to have the image. Using the image only, the container will be able to work. Because when you create a container, it's just nothing but an empty process. In real time, you cannot have an empty process. So far I have been telling, but if you go back and think, can I create a process which is empty? No. So that way, in order for you to create a container, what you need is an image. So this is where there are plenty of images available in the Docker, but that will not be available on your host machine. Just like your code in the Git in central repository, now in Docker, there is something called as Docker Registry. This is where all the images are stored. Okay. Now in this, there will be different images available. So when you are working in the workflow, depending on your need, you are going to choose an image, and then you are going to first download it to your machine. And then using this image, you can create as many containers that you want. Okay, so what is going to happen? All you're going to do is create one empty container, put the image inside it, and this becomes environment. So this way, using this image, you can create as many containers that you want, and each one of them will be exact copy, and whatever that you do inside this container will remain inside that container. So this is where, when I was explaining using Docker, what you can do. So the first part, what we are going to do is container management. So container management means from the registry, you are going to download a specific image of your requirement, and using this image, you can create as many containers that you want, and all of them will be running on your host machine. And remember this, if you create a container, this will remain on your machine, because the daemon is going to manage it on the machine where you have installed it. So this is one of the important work what we'll be doing, which is called as container management. Okay. Now, along with it, we can also create our own image. So it is not mandatory that you are going to have one image and you are supposed to use that. So you can create your own image. If you want to do that, then that is where using Docker, you can do the second part of the work, which is called as image management. Okay. But what happens is, just like Git, when you do a check-in using your workspace, that will be available only in your local workspace, right? So now if you want to share that to everyone, you are going to share it to the central repository, because each one of us, when we work, we will be trying to take the image from the registry to our local machine. Okay, so the same way, if you want the image that you created, which is available in your machine, to share it with others, then you are going to share it to the registry. So this is where your day-to-day work will be. Either you can use an existing image and start and stop or restart your containers, or if needed, you can also create your own image, but you need to make sure that the image is shared back to the registry so that someone else can work. Okay, so these are the components of the Docker system. Or in day-to-day, what you're going to do is you're going to choose an image and download it, and start creating containers, start and stop. So this is what we are going to focus in the first level. Okay. Now,
Adam, a quick question, Adam. Seems to be
yes.
concerning for me. So are there any moderators who are managing in Docker registry to receive the images that users are creating? Is it managed or is just unmanaged? Anybody can upload or something?
No, it's not like that. So just like that's the reason I told you it's exactly like central repository. So if you take Git is what you're going to work on your local machine. But to manage your central repository, you need to have a separate tool or a separate account to manage. So it's not that anyone can work. So I'll talk about it in the next slide so that you'll get a clarity.
So what I'm scared of is if due for specific application and I happen to check the Docker registry and I happen to like a specific image which fits my requirements, and if I download it, and what if I'm not sure the person who has created that image has actually uploaded that image with some malware or virus?
Okay.
How would I know?
I got your question. I'll answer it in the next second slide from now. Okay.
Okay,
Just give
sir,
me some
sorry.
time. Okay, if everyone is clear with the system, so now if you understand, using the Docker or the Docker daemon, in fact, what you are going to create is a container which will be available in your machine. But for doing it, what you need is a image. So that way, if you're not going to create an image, then there is someone who would have already created an image for your organization and stored it into the registry. So all you need to now know is what is the image that you want to work, and download that image and start doing your work. Okay, so this will be your workflow. So now the only two things that I want to explain for the day is, so now we know container, now we understood what is Docker, and then we understood the difference between Docker or VM and container, and then we also saw what is the overview on how the architecture of Docker is. So the key or the very important component of the Docker is the image, because to again reiterate the sentence, container is nothing but an empty box. What makes it an environment is the image that you put inside, correct? So that way, now if you understand what exactly is the image, what does it contain? So image is nothing but a collection of file system layered one top of the other. Okay, now the best way to remember this is, again, I would say sandwich. So like how you can have different layers of a sandwich, right? Now for example, I can have one layer of sandwich and someone says that, okay, I want a double layered sandwich with two patty, right? So that is how when you take an image, not every image will be the same. So it depends on how many layers that you're going to put and what is that layers going to contain. So the layers is going to contain an application or a library or some kind of OS related files that you're going to have. So an image is nothing but layers of file system. But what makes it so special is that when you take a VM like VMware, an image has a kernel in it. Whereas when you consider Docker, the image that you have has everything for the OS to run other than the kernel. Okay, so that is the basic difference. So that is why when you take an image and create a container and start running, it will not allocate any RAM in the beginning. Only when the application runs, you need the RAM. Whereas if you go to your regular VMware, as soon as you create a VM, why is it a RAM is allocated? Because there is a kernel inside it. So that is where as soon as you create a VM, RAM is allocated. Whereas in container, it is empty. And when you put an image, because of what content that you have in the image, you will be getting everything inside it. So this is where, depending on your need, you need to either create an image which will have everything that is needed for you, or choose an image which has some particular files or libraries or application which is needed for you. So there are two cases. So in most of the cases, someone in your organization will create an image which will have all the application and all the supporting libraries and the particular OS files needed for you. So all you have to do is download that particular image regardless of your host machine. I can just create a container and I will make sure that everything is available inside the container. So how will you get it? Whatever is there in the image, you're going to get. Okay, so that is where image is nothing but layer of file system. And there's a specific reason why I keep saying layer, because as we move on to the real time, we will be able to see that. And then when you say an image, by default, image is read only. So you cannot modify anything when it is as an image. Only when you create a container and you put a copy of the image inside it, the content becomes read write inside the container. Okay, so inside the container you are free to modify, do whatever, but it is just a copy of the image. So the image still remains as read only on the host machine or the Docker machine, so that you can make multiple containers, which is going to be the copy of that. Okay, so remember the workflow is you're going to download the image and create a container and put this inside, or ideally if you say creating a container, Docker will do all those things for you. So it will create an empty box, put the content of an image what you have told, so that whatever is the content of the image will be coming inside the container in a read write fashion, so you can go and start working on it. Okay, so that is where in Docker what's more important is the image. Okay, and to talk about the last topic, which is Docker registry. So now I was telling you, okay, image is the most important one, because in your machine you are just going to create an empty container, put the content of the image. So that way you need to know the image on what is that you want to take. Now in that, when you say registry, just like Git, that is the reason I compared it with Git. So similar to Git, now we will be having a central registry from where every one of us can access. So typically, if you see, a registry or a Docker registry is nothing but a centralized location where you're going to store all your images available. So this way, when you say a registry, just like Git, we have GitHub, which is open source, and we also have enterprise versions like GitLab or different things, right? The same way in Docker registry also, there are different kind of registries. One is public, the other one is company. That is within the enterprise, if you use, then we call it as private registry. So typically the Docker hub, whatever that you're going to use, is what we call it as public registry. So when you're working on a day-to-day, the default registry that you will be using for your practices will be Docker hub, which is public. But within an organization, you cannot use public, so you will be using a private registry. So that way you can go with many service providers. Like if you go to AWS, they also have something called as ECR, or if you go to Azure or Google Cloud, they also have separate container registry. Or you can also install tools like JFrog Artifactory, and using that you can create your own private registry on hosted on some machine. So that is where, if you're going to have a private registry, then only within the company you can download an image and you can put the image. Okay, and it's not just that registry is used for storing the images. You can also do a scan, because just like Git central repository, not everyone will have permissions to store an image into the registry. So a registry can be used to have a control on who should be downloading and who should be uploading an image into the registry. So only authorized people should be doing it. And at the same time, you can also do something what we call it as scanning, so that you can make sure any image that is uploaded into registry goes through your vulnerability checks and make sure that that is being under the compliance of your organization. Okay, and additionally, we can also do something called a signing, so that you can certify saying that this is the right image that you are trying to give from an organization. So all these things can be done using a Docker registry. Okay, so that's where, when you are working as a regular user, you would be just getting a download permission of an image, download the particular image of your interest and work. But being in DevOps, creating containers is not just one work. So that is where, as a regular user, container management is what you're going to do. But as you focus deeper into the DevOps, you can also take up the responsibility of image management. So that is where you should know what is the image that is needed for the organization, and make sure the content of the image is hardened. So you're not just going to blindly put everything as it needed. Just like how you are going to have something on a machine, you are going to make sure whatever the content that is going inside the image is a hardened version of application or OS, and that is what you're going to store into the private registry. And you can do a scanning of all the images available to make sure that they are following the industry standards. So that's where you are going to use registry for doing your image management, and on the other side, as a regular user, you're going to install Docker on your host machine, and using the client, you're going to download the image, create containers, start or stop it depending on your need. Okay, so I wanted to show you the installation, but typically I don't think I have time, so let me take it up on the next session. But other than that, I sincerely appreciate everyone to bear with me for such a long time, and thanks for attending. And again, these are my Facebook link, and I wish everyone to like and share it. Other than that, I'm now open for questions.